Okay, I wanted to go through example 4, part A again real quick because it just looks better with a picture. So you want to use a calculator to approximate the degree measure to 1 decimal place or radian measure to 4 decimal places of the angle theta subject to the given conditions. So on part A, you're trying to find the third quadrant angle. So it's saying between 180 and 270. So that's the third quadrant. You're looking for an angle theta between 180 and 270 such that the cosine of that angle is negative 8/11ths. So if you punch in negative 8/11ths and you hit inverse cosine, your calculator is going to give you 136.7, all right, because that's in the range for inverse cosine, and so that would be right there. But that's not in the third quadrant. You want the angle that's in the third quadrant that has that cosine. And that angle will have the same relative or reference angle that this one does, 180 minus 136.7. So that angle is 43.3. You're going to use that angle to find the third quadrant angle that actually has a cosine of negative 8/11ths. So it will have that same reference angle. And so to find out what the actual angle from 0 degrees is, you would just do 180 plus 43.3. And so that would be here, and that's 223.3. So that's the angle that has a cosine that's negative 8/11ths in the third quadrant. Okay, so find the exact value of sine of the angle whose cosine is negative 3/7. Or you could say sine of inverse cosine negative 3/7. So the first thing you want to do here is remember that the range for inverse cosine is from 0 to pi. So it's the first and second quadrants that you get angle values for inverse cosine. So we're looking for the angle whose cosine is negative 3/7. That is a negative cosine, so that means it's going to be in the second quadrant. Since the cosine of that angle is 3/7, that means adjacent over hypotenuse. And so to find the other side so that we can figure out the sine of that angle, all we need to do is use the Pythagorean theorem to find the y coordinate. And so we just put all that into the Pythagorean theorem, and we have that that is going to be 2 times the square root of 10. And we know we can find the sine of that angle because it will just be opposite over hypotenuse. So this is equal to 2 square root of 10, which is positive, over the hypotenuse. So it is a positive value because in the second quadrant, sine is positive. Okay, example 8, write the expression tangent of the angle whose sine is square root of x squared minus 16 over x as an algebraic expression for x greater than 4. So all we need to do is figure out where this thing is, what quadrant it's in, and then we can figure out its tangent. So the angle whose sine is square root of x squared minus 16 over x, where x is greater than 4, is going to be positive. It's a positive value, so it's going to happen in the first quadrant. And if we draw that triangle for that angle, since the sine of this angle is square root of x squared minus 16 over x, the opposite side is the square root of x squared minus 16, and the hypotenuse is x. And so to find the other side, which I'll call y, I will just use the Pythagorean theorem. So y squared plus the square root of x squared minus 16 squared is equal to x squared. So y squared plus x squared minus 16 is equal to x squared, and the x squareds cancel out. So y squared is 16, which means that y is 4. And so since that side is 4, the tangent of that angle theta is just going to be opposite over adjacent. Okay, a yardstick casts a 4-foot shadow when the sun is at an angle of elevation theta. Determine the angle of elevation of the sun to the nearest tenth of a degree. So we have this picture here, and all we need to do is find theta. We have opposite and adjacent. So we have tangent of theta is equal to 3/4. So inverse tangent of 3/4 is equal to theta. And if we punch that into our calculator, we get that theta is about 36.9 degrees. Approximate each expression in radians to 4 decimal places. All right, so you're looking for the angle whose cosecant is 3. If this angle, whatever it is, has a cosecant of 3, that means that it has a sine of 1/3, because sine and cosecant are reciprocals. So I can just rewrite this as an inverse sine. Okay, so you just have to make sure that your calculator is in radian mode, and that if you punch that in, you are going to get about 0.3398 radians. So for part B, you have inverse cotangent of -3/4. In other words, you're looking for the angle whose cotangent is -3/4. If its cotangent is -3/4, that means that its tangent is -4/3. So we're looking for the angle whose tangent is -4/3. You're going to make sure your calculator is in radian mode again and punch in inverse tangent of -4/3. That is going to be about -0.9273.